This is Space Engine. I've used this program before in a lot of my videos, and it is an immensely helpful, incredibly fun program. I can't even call it a game. It feels graphically like it should be a game, but of course there's no objective and there's nothing you do. It's really just a universe simulator, and I find myself using this program so often to just pop in and play around with it, and before I know it, I've lost hours and hours and hours. So I want to do the exact same thing right now and just sort of take you along with one of my mental journeys through this, and hopefully keep it an abridged version. So this should look familiar. This is Earth, obviously. Earth at night on one side, Earth daytime on the other side, because that is the side that faces the sun. It's really neat stuff, if you ask me. It always blows me away to think that every individual who ever lived and every story that's ever been written has just taken place on this ball, this rock. Sounds so unromantic, but really from a larger scale, from a galactic scale, it's really quite unimpressive. Not a whole lot going on right here. Let's go ahead and turn the interface on so we can look at our stats. It's got the mass of 1 Earth and the diameter of 1 Earth. Look at that. What a surprise. Look at sun for some different number. Look at the sun for some different numbers, and click on the actual sun, not the system itself. And there you go. Got the distance of... oh yeah, that makes sense. The distance 1 AU, meaning we are about 1 distance of the Earth to the sun. That's because we're at Earth. That's where these measurements come from. I'm just sort of starting to lay those down as the found word for some numbers that I'm going to be looking at in the near future. So look at that. We got 1 moon, a cool 33 degrees Celsius over this thing, rotational period of 24 hours, roughly 23 hours and 56 minutes. That surprises me. That's weird. And an orbital period of 1 year. This is just the unremarkable basis for all of our measurements, because it's where we happen to live. You can see the moon chilling right back here. Not much special about that, but we're just so small and so slow, and it's so hard to realize that we're just not special. So we start cranking the speed up, and we're leaving Earth at about the speed of light right now. This is it. That's what we're looking at. And we're gone. Moving on to bigger and better things. So we'll crank it up 10 times the speed of light, 100 times, 1 times the distance between the Earth and the sun in 1 second. 10 times that, 100 times that, 1,000 times that, and now we're going 1/10 of a light year in 1 second. And notice we are still just barely seeing movement of other stars, even though we pass through our system just like that. That's as long as it takes. And yet the sky is still mostly static. That is how far away all of these other stars are. So let's speed it up a little bit, shall we? Go about 1 light year per second. Now we can actually see a little bit of movement. Our little galactic neighborhood starts becoming a little more obvious. And as we look around right here, let's rotate it like this. We see probably Sirius, if I had to guess. Oh, Centauri. Are you Sirius? There is Sirius, chilling right down here in the corner. You definitely start to recognize a lot of the same stars, because obviously they never move. They've never moved for the lifetime of all humanity. These are the static, unchanging things to us, but on a galactic scale, they're not unchanging at all. They're moving, and they're gonna crash into Andromeda. Let's check out Andromeda. Okay, who's just chilling right there all the time, no matter where you go in the galaxy. Every one of these hundreds of billions of stars with their hundreds of billions of planets, and Andromeda is just chilling, visible to every single one of them. So our view of the neighborhood obviously starts changing. Our night sky is only static because we never really move in relation to it. But as we start moving, we can see, you know, if you can make out the little cloud right there, there's nebulas, there's other stars, there's giants. Look at this, there's a giant right here. I can just tell how bright it is. Oh, that's a main sequence, huh? It's a really bright main sequence. As we start traveling, there's so many. Every single dot on the screen right now is just another system that holds stars and Possibly life? Who knows? We don't know yet. I mean, I'm presuming that definitely, yes, there's other life. That's just, it's, to anyone who just understands the scale of how many stars there are and how many planets there are, it is just undoubtedly obvious that life is not only elsewhere in the galaxy, but probably just all over the galaxy. And let's just stop and pick one at random. Look at that. An orange dwarf with 10 planets. Let's go get a glimpse of this guy down here. Look at that. A nice bright star. It's not quite a binary system. It's got a planet real close to it, sitting at 400 degrees Celsius all the time. Almost getting its face melted off, but not quite. It's just very, very hot. And it looks like all the other planets surrounding the sun, those are actually asteroids if I had to guess. Yeah, there's only 10 planets in the system, so there's just a whole number of asteroids just surrounding this guy super close that are basically just balls of super hot rock orbiting the sun. And if we visited this star system and we found any place even semi-hospitable, still sitting at 300 degrees, negative 98 degrees. Well, that's kind of better than melting, I guess. Yeah, I mean, it's cold. Cold as all hell, but it's not quite as cold as space. So if we were sitting right in here and looking out over this star, this is what we would see. We would see the Milky Way down there, the large and small Magellanic Clouds, which also exist outside of the Milky Way, and then a nice orange star chilling up in the sky. And this is even at daytime on this planet. You can see a decent amount of stars in the sky, which means it probably does not have a very thick atmosphere. That's enough of this lifeless little planet. Let's go ahead and take off. Let's leave this guy. Oh, there we go. Let's start tearing our way through space again. As soon as we can see the movements of some stars. Alrighty, that's what I'm talking about. And let's pick up the pace a little bit, shall we? And just look for stars. Any star that looks interesting possibly contains life. And I'm going to try to look for life right now. I'm going to do so by looking on the edges of our galaxy. So let's crank up the speed, turn off the rotation, get way up here. And look at this. Look at the beauty of the Milky Way as we stare at it. We've left the thickest portion of stars, but there's still a few chilling every once in a while out here. Look at you, an orange dwarf, a blue giant, a globular cluster. I just like saying globular cluster. And I'm looking around for a planet with life right now. I haven't been having a whole lot of luck. They are fairly rare, to be perfectly honest with you. That's a blue luminous supergiant. Really awesome name, but not in my interests to check out quite at the moment. And I'm just looking somewhere around here. I'm really surprised at how rare they are, actually. Normally I can find one in just a few clicks. Blue main sequence, blue binary main sequence, blue main sequence. Well, I didn't quite find life, but I do see something else interesting down here. There is a quadruple orange dwarf. That means there are 4 suns, 4 stars that share an orbit in this system. And it looks like there's 2 bright lights. Each of these bright lights is probably 2 suns. So let's zoom in a little closer here. Let's check out this system. Zoom in right at the center here. Oh, we gotta get closer than that space engine. Let's just get right up on cozy. There we go. 2 stars orbiting each other at the center of this system. Let's speed up time a little bit and see that that's what they look like. You can see a string of asteroids rotating around behind the stars. A few moons on what I presume is a gas giant. Let's check it out if we can. It's a warm asteroid. I might have to slow down time for this. Yep. Oh, not temperate ice giant. Interesting. And this is at a nice 4 degrees Celsius. This is doable. This is doable. It's still a giant, so it's got 2.2 times the gravity of Earth, but it's just really interesting. It's got an orbital period of 66.623 and a rotation of 66.623, which means it is tidally locked facing the star, the binary system right here. So as we speed up time, slowing down time. As we speed up time and stare at this thing, well, I guess it's not tidally locked. You can see it rotating slowly, and it doesn't seem to be in time with the star. Those numbers don't seem to add up to me, but I'm sure there's just something that I'm not understanding. Anyways, so that is just one system. They could just imagine if life started there, and we looked at this, the very center of this thing, it's got an orbital period of 1,094 years. That means that every 1,094 years, let's speed up time a little bit, these two spend time getting slowly closer and closer and closer. Let's set this very center as our goal. Those two are rotating. This entire system is shifting, and they're getting closer, well, actually further and further away from this other star. So there could be a situation that exists where there are they perfect opposites of one another? Do they ever get closer? I'm really curious. It doesn't look like it. It looks like the closest they ever get is right about there. So imagine how crazy that would be if every... I can't even tell. What is that? Distance, main body, planet. Well, I don't care about the distance. I care about the rotational period of these systems. 1,000 years and 1,000 years. Imagine if every 1,000 years is when you got close enough to another star to possibly be able to send radio signals, or even consider sending life back and forth to the other star. That would be an insanely cool thing. But I got so distracted. But I'm talking about life, and I'm talking about tidally locked stuff, so I'm going to sort of cheat here and look at a tidally locked life Terra. Let's go ahead and zoom in on this right here. This guy, this planet is so interesting, because when it's tidally locked, that means the same side always faces the star, and we can even see another cluster way back there in the galaxy. Which means most of this planet is just ice and snow back here, but there's just one surface on this side that always faces the sun. This is probably where all the life takes place, perhaps with a thin layer of polar life over here, but it would take... I don't even know. It's impossible. It's really hard to imagine the situation that would come about where life would exist on this side of the planet. There's just no energy that makes it back there. Can you imagine how interesting the theories and the religions of the life forms that arise here, if they were intelligent, what they would come up with to describe this planet? It's blows me away. It's mind-boggling. So let's just step on down at the surface real quick. Definitely not so pretty once you get down this close, but it's still pretty neat below the cloud layer and down among the mountains and valleys. And we could just pick a random spot. Say we hiked to the top of this hill on this planet with life. And what blows me away more than anything else is that, yeah, this probably doesn't exist. Chances that the people who designed Space Engine designed a planet that just happens to exist with life out in the real world are small. So this is just generated based on, probably if I had to guess, Drake's equation of whether or not life actually exists. We got like a weird push thing where we're like falling down. It's so strange. But it's not crazy to imagine the scenarios that could look very similar to this on planets with life. And as we speed up time, we actually see the clouds passing just like we do here on Earth. We'll turn off the orbits and just look up at the sky. And you'll notice it's never nighttime because the sun is always there. We are tidally locked. We are on the warm side of the planet, which means they would never really be able to easily observe space like we do at nighttime, because the huge reflection, the glare of the sun would get into all of their instruments. It's just mind-boggling, the implications of what it would mean to live on a planet like this, and to know that even though it's not this particular one, that planets like this probably do exist with life out in the universe. We just don't know where yet. And what blows my mind also is that this looks so similar to our Milky Way, but it's not. This isn't the Milky Way. This is just another galaxy with this soup of stars everywhere we look. Everywhere. There's a white main sequence, a binary white main sequence, a binary blue main sequence, a yellow giant, etc., etc. There's just so many stars in every single galaxy. The chances that humans are the only life are so insanely small. It's crazy to believe that we are the only life in the universe. I spent this whole video traveling through our system, or through our galaxy, and through this galaxy, which I don't even know what this galaxy... Oh, that is the Milky Way. Huh, I guess I had it wrong. Huh. Well, that's even cooler, because now it means we can just push through space, and look at this. Each one of these galaxies that we're passing by right now has just as big of a soup of stars as the Milky Way, and we can turn up the speed to 326 megalight years per second, and we just keep going. There's no end in sight. Every single one of these galaxies has billions of opportunities for life, and stories to be told, and things to explore. And let's stop for a moment, slow it down, and look around and realize that we are actually looking at the structure of the universe. Maybe not in the exact way that it is in reality, but in the same way that there are superclusters that have galaxies swarming around them, there are huge plots of the universe. Most of the universe is just wide plots of empty space. How about over here? We'll see we're getting close to this star and we pass it, and suddenly, look, all these other ones back here are so far away. There's just nothing over here. We're still going just as fast as we were when we passed that other star, but there's just a huge blob of empty space right in the middle of the universe. So, let's pick it up a little bit more. We start to see that there's, I guess, I don't know what you would call it, like a network. You can see we start to pass through areas. Let's even turn off the motion blur so we just see dots. And as we turn around and look as we travel, we see how there's possible membranes and structures to this structure of the universe. I don't know how else to put it. Areas where they stick so close to each other. There's practically a wall of galaxies right here that we're passing through to get from one point to another. And some of them are just so bright, like this one back here, that it's red-shifted. The universe is expanding so much in between here and there that whatever color it is, it appears red. So let's get right up next to it. Whapa! And it's actually a nice white color. Sort of actually quite a boring galaxy, if you ask me. It doesn't have the same gorgeous shape. It's more of a cluster of stars. And as we get inside, every single one of these, any one of these could have life. We find possibly any of them? Nope. I've just been so bad about that this time. Let's just pretend for a moment that one of these had life. This supergiant, highly doubtful with a star that looks like that. So we'll check out one of the planets in the system here. Disable orbits, and oh, look at that! There's a black hole orbiting this giant. We'll zoom in right up next to this guy and get right up next to the black hole. It just really just looks like the bending of light, nothing else. So yeah, really no light could possibly take place in the system. That's not that I could ever imagine in a million years. I don't know how that would be possible. But as we look around for, see, that's the problem, is I always end up going to supergiants because they are the biggest on the screen. There we go, a yellow dwarf, one with life. Interesting stuff. So looking at a scorched desert. No, there's no life there, but you can see all of the heat is just blasting all the stuff off of it. A hot ice giant. Let's see exactly 9 planets in this system. And over on this cold ice giant are 5 moons. So let's check out the cold ice giant. On one of these 5 moons, life exists. So we'll pop it open and look at that. A temperate desert with life that is organic, multicellular, terrestrial. So that could possibly mean intelligent life just sitting on this random planet, on this random moon, on a random planet, orbiting a random star in a random galaxy. And they would have their own stories to tell and their own evolutionary process, their own ways of life, and their reasons for their beliefs. And to think that there's people out there that think that we're the only life in the universe on our one little rock, just like this rock, or any of the billions of others connected to these billions of other stars. So This has just been a little journey through my perception, my thoughts as I explore Space Engine, and I'll go ahead and leave it at that. I'll talk to you guys later.